Newton's laws. We're going to very briefly introduce Newton's laws, which you can find many more videos. And for those of you in the current class, you'll have much more of this in biomechanics. But Newton's laws of motion have many applications to movement of the body in kinesiology and specifically in biomechanics, especially motion analysis. These laws explain the relationship between force, inertia, and motion. And inertia is basically the thing in between the force and the motion. So when we have a activate our muscle, we have to overcome the inertia of the limb to create that motion. So the law of inertia. You may have heard this, that a body in motion tends to remain in motion at the same speed in a straight line unless acted on by a force, or a body at rest tends to remain at rest unless acted on by a force. So this concept of inertia is that inertia is this resistance to action or change. And it's basically how big or how much mass something has, which is the magnitude of its inertia. So a large truck is harder to slow down than, say, a sports car. So if you had something in your way on the road, you would need a lot more time and force on the brakes to slow down a large truck compared to a lighter car. In human movement, inertia refers to the resistance to acceleration or deceleration. So as we're throwing a ball, right, we have to move our whole torso, then our upper arm, our lower arm to create, say, a throw. So our muscles have to overcome that inertia of our body to result in the acceleration of the ball. Um, for also in human movement, it's easier to move a small person than a larger one. And say in football, that is why some of the linemen tend to be large human beings with large inertia, so they resist motion. Muscles produce force to start, stop, accelerate, decelerate, and change the direction of the motion. And they are overcoming the inertia of our limbs. The second law is a law of acceleration, which some of you may know as F equals ma, force equals mass times acceleration. So the law states that a change in the acceleration of a body occurs in the same direction as the force that caused it. The change in acceleration is directly proportional to the force causing it and inversely proportional to the mass of the body. So if you want something to go fast, have a high acceleration, and it has a large mass, you will need a large force. The mass, in terms of our body, is the amount of matter in the body, and it does affect the speed acceleration in our physical movements. So muscle force depends on the size of the person or the limb and what the activity they intend to do is. The final law, Newton's law, is the law of reaction, sometimes called action reaction. And it states for every action, there is an opposite and equal reaction. So if you're sitting right now, you are applying a force to the chair, and the chair is applying an equal and opposite force to you. Otherwise, you would either fall to the ground or the chair would push you into the sky, I guess. So as we place a force on the surface by walking on it, the surface provides that equal and opposite force back to us that allows us to kind of move through the body or through the world. And you may know it's sometimes easier to walk or run on a stiff surface than on something that has a bit of give. So wet grass or sand is a lot harder to project ourselves forward walking or running than on a stiffer surface. And this force that we talk about in Newton's law, when we're talking about applying it to the ground, we call in biomechanics the ground reaction force.